We're just waiting on Dexter to show up, so we should be starting fairly soon. But while we wait, as you all know, this is going to be AI That Works. We've got a couple of questions that we can take while we're just hanging out, waiting for Dexter to show up. But I think today's episode is going to be really fun. We're going to start doing some live coding, which usually we go to whiteboards, we do all the other things, but we're just going to go straight into it. So I'll be back in a couple minutes, but I'll see you in a second. All right, Dexter is actually having some phone difficulties. His phone is bricked, as we have learned, and he's all the way over in Egypt right now. So international travel is exciting, to say the least. But I think today's episode, we'll get it kicked off. Hopefully Dexter can join a few. And then as we go start, we're just going to go right into the coding side of it. As we're doing this, let's start talking about the most important thing, which is if we're going to go and talk about dates and LLMs and time zones, how do we actually make them work? There's a lot of ambiguous questions that come out of it. For example, I could say, let's go meet up next Tuesday. And I think today, being Tuesday right now, at least on the West Coast, it's unambiguously clear. By that, I mean November the 18th instead of November 11th, which is today, or even the Tuesday after that. On the other hand, if we were yesterday on Monday and we are saying let's meet up next Tuesday, that almost probably means to meet up on November 18th as well. But yesterday, if we had said let's meet up next Saturday, I could see how someone could misinterpret that and say that meant actually the upcoming Saturday as opposed to the following. And as date times happen, it's really hard to get a model to go and obey them. If your users are in a different time zone than your servers, and you go and the user says let's meet up at midnight tonight, the LLM can't possibly understand that if you're normalizing all your time zones to like UCT or your server's time zone, the Pacific Coast or US East 1. So it's important to be really, really careful about how time zones make sense, because if you don't deal with dates and times correctly, a chat thread that is otherwise going perfectly can easily mess up and give you the wrong information. So to get started with today's conversation, I'm just going to go straight into screen sharing and start going through code, because I think there's not much whiteboarding to do here. We just have to write some code and prompt our way to success. And what's awesome about this problem is it's actually not that hard to get right. So let me know if you have a hard time seeing my screen. I'll try and zoom in. And as we go about it, we should hopefully be good to go. So I've already started a Python project here, but I'm just gonna add BAML py, run BAML CLI init. Cool. And now we've got our project. As we go about this, let's make the date time evaluator. So the first thing to go here is to talk about and think about exactly how are we going to actually build some of these functions. So the first thing that we're going to do is just say something like, let's say we have a function that's going to say we're going to get we're going to extract relevant dates out of a conversation. text string. And we'll do like, for now, we'll just return a string array. We'll go here and we'll say client, OpenAI, GPT-4o mini. I don't know why I like that model. I just do prompt. I think I like it because it's fast and cheap. Extract all the dates from the following text, ctx dot output format dot role user text. So we've got a really, really basic prompt, and we'll go about this. And why am I extracting dates first? Well, I think the most important part is, can I have the model go understand the dates? Understanding dates within semantics is even harder, but perhaps what I want the model to do is just like normalize every date that comes across some sentence in a much easier to understand way. So let's try and do that. So what am I going to do here now? I'm going to write a test case. Dates. Functions. Extract date, and then args. Oops. Text. And the text will be, let's hang out next Friday. So we'll do relative dates. We'll make a couple test cases off the bat. We'll do this, November 15th, 10 a.m. Date of time zone. 1 second. Get rid of these time zones here. At 6 p.m. Cool. And now as we go about this, let's think about how we can go answer this question really quickly. Now when we go run this, let's just run this prompt really quickly and see what happens. So the model seems to understand November 15th as a date, but the first question I'm getting is, okay, what about November 15th versus 11/11? How do we standardize date formats? Well, this is where it starts to get a little tricky, so let's just do this really fast. We'll do year, month, date over here, and then we'll return the date. And now when I do this, I get something a lot more standardized than what I could have done before, because no matter what happens, it will just convert stuff to next Friday and everything else. So let's run actually all the tests, because I don't want to just run this one test. So absolute date, it got right, 11/15. Date with time zone, it got right. And then relative date, it did not understand because next Friday doesn't mean anything. Well, there's a couple other ways that we can do this. So we can say like absolute date, relative date. And what you can do here is like you can make this a string. String at description. I think there's a standardized timing format called, it's not like, let me look this up really fast and tell you what it is. Relative timing. I think it's like, there's a very standard way to go do this. I think you're going to say, so we'll just try this. And now instead of date, we're going to get a boom. So now the prompt is still very simple. It's either going to be year, month, date, which is absolute, or a relative time. And one thing about what this did, let me rerun all the tests again. And this still works. It got us an absolute date. This got next Friday. Again, not very useful because next Friday still can't be read in a good way. So I think there's a use date, use duration strings like so there's different ways to do this. So for example, you could use a duration string like this format. Let me ask you what this format is. And now we get P7 days. Why does it do P7 days? Because the model, for some reason, thinks that this is a week from now. It's still not understanding the problem. So let's think about what we're really doing here. The reason that this is struggling is because no matter what we do, the model isn't able to have context on what the day it is today and how you respond to a date in many different formats. So for example,
like when you're like 10 minutes late for the podcast.
It's very different than saying, something like, let's hang out 2 days from now, where this test should work with 100% accuracy because this is a good way to represent the data. P1D, P2D. It's very easy to understand what you're doing here. On the other hand, a question like next Friday is much more ambiguous, and this data model doesn't actually represent this. So let's try this again.
Yo, Bob, can you hear me?
Relative date. Relative days. And then we can say from nearest. And then we can put like we can put some sort of like date type on here. So let's just say like string for now. And then we can say relative date, string, description. So we can say there's a source that comes from here. There's some relative source, and then given the source, here's the relative date string that we have. So if we start with this string and we do this one will still work. Oops. With source. And now we'll go into a different question. That is, if we're actually going to go about and answer this question, what does this do? Relative days. Well, let's try and run this. It still didn't understand. So let's try and add a source date to this. Source. Let's say Monday, November 10th, 2025 is the date that I'm going to give this. And we'll add another optional parameter into here called source string right here without computation. Reference date. Boom. Let's try running this query really fast. If we do this, it's still not working. Let's try again. I suspect it's because these types are kind of confusing, so let's just add more metadata here. And try running this now. So now it kind of understood. It was able to go and say, I want a relative date, and the date is going to be 4 days from now, but it wasn't able to understand that it's using some source string.
Bob, turn your sound on.
So let me pause one more time and try and think again through this problem as we're going to go think about this in real time. Oh, Dex, you're there. I can't hear you.
Dude, I've been here. Turn your sound on. Can you hear me?
Yes, I can hear you now.
Fantastic.
Okay, you're back alive. Sorry. I wasn't sure when you showed up.
Dude, you missed it. I had a killer joke about not understanding date and timestamps.
Oh,
Look, guys. Also, your echo is like echo now.
Oh, let me try one more time. Are we good?
Can you hear me? Can you hear me?
Yes, I can.
Okay.
I think we're good.
Amazing. Sorry for the interruption. I completely derailed everything. My God, do I have a story for you, but I just, the amount I went through to get here. Oh, man. Anyways, back to dates and times. I'm so excited. Keep going what you were doing. I'll ask questions. We'll do the thing.
Let's do the thing. I'm so glad I switched screens. I was like, I suspect Dexter is going to show up anytime now. Let me switch over really fast. Let me find the window. Cool. So as we go about this problem, let's first reason about. So Dex, I'll catch you up. I don't know where you're caught up to.
Catch me up.
Okay. So the problem is we want to go ahead and answer questions like, let's hang out next Friday. Let's hang out 2 days from now. The meeting is on November 15th. The meeting is at November 15th on 6 p.m. And there's all sorts of different semantics that get tricky here.
Can you add another one that is like the podcast is at 10 a.m. PT, just like it is every week?
Oh, yeah.
10 a.m. PT on Tuesday? We'll see if Claude is smarter than me.
Tuesday. Cool. So what's really interesting about this is given all these date times, what I find personally really fascinating is there's so many different data models that you can use to represent all of these. Because, for example, saying something like the podcast at 10 a.m. PT every Tuesday is a fundamentally different question than saying the meeting is on November 15th, because this usually implies that there's a single occurrence. This is a regular reoccurring meeting. That means the year is not very as relevant. Even the date and everything is not relevant. In fact, in order to know when the next podcast is, you have to know what today is. Otherwise, you can't possibly answer the question relative to the user. And whereas everything else is kind of anchored to a very, very specific date. So I think the problem that most people run into when they try using dates with LLMs is, as we're just seeing here on all these test cases, there's no single way to really represent them. They all are genuinely very, very different scenarios. What's your first instinct, Dex, before I go into like at least what I have found works for this kind of scenario? Oh, did Dex die again? Dex is disappeared. We'll bring him back in a second. I suspect he's having internet issues. But at least for me, when I first think about this, my instinct is... Welcome back, Dex. You are having massive echo. Hello. Can you hear me? There you go.
Okay, I'm muted. Are we good? Okay. Sorry.
You're gonna have
I had to leave and come back to switch to my AirPods.
That's okay. I think you're going to have some echo based on the headphones you're using, but that's totally fine. But while we're here, as I go about this and I explain the few edge cases that we have, what's your first instinct here, Dex, when you look at this and you're like, I want to go ahead and go make this slightly better? How would you address the wide variety of date questions that people might be asking here?
Number one is inject today's date into the prompt.
Okay, so you want to have like a today in there. So I'll call that source. And for now, we'll just use Monday, November 10th as our source everywhere. What else would you do?
Can you show me the extract dates, the prompt?
Well, we'll update the prompt together because I actually want your thoughts on it. But I mean, like in terms like I guess here, I'll show it to you. This is what we have. I have something very, very simple, at least for now.
Okay.
Yes. So what's your first gut instinct on how you would solve like the wide variety of dates that we have here?
I don't know. I mean, I would want to just run one of these and see what we get, and then I would tell you what needs to change.
How about we run all of them?
Okay. Let it rip.
Let's run all of them, and let's just look at it. So after running all of them, here's what we've got. Absolute dates, which was absolute time. Absolute dates was this one, I believe. Where'd it go? The meeting is on November 15th. I think that detected it correctly. It detected 2025, 11:15. That worked. Absolute time did not seem to work. But that makes sense because like 10 a.m. PT every Tuesday, you can't really extract the date from that. It's very hard to, at least. Dates with time zones is this one, Monday, November 15th at 6 p.m. That seems to work. But it didn't get the time because we don't model the time yet. Relative dates is this one. Let's hang out Friday, which is 4 days from Monday, PD4. And then relative dates 2 days from now is PD2.
Okay.
So
cool.
Some of it seems to be working, but I find that like what is not recurrence times. So when you see that the recurrence time isn't working, what's your gut instinct? How do you prompt your way out of this hell?
I would, my really naive, without thinking too much about it, is I create a new class that is recurring date.
Sure. Like, why not?
Cron string is fine. Okay. And maybe I also want to know, like, when is the next one? Like, next
Yes.
occurrence.
So what's interesting about the next occurrence is technically if we have a cron string, we can compute it using software,
Okay, fair.
right? Like we don't actually need to go do this. We need to take the cron string and go process. I've actually never used the cron string. I have no idea what this means. So we can just try this, and then let's try.
That's insane, by the way, that you've never used a cron string. I do not believe that.
I really have not. Is this correct? I have no idea. I want to ask Cursor to explain this cron string to me.
The time zone is wrong, or it's not time zone. I would expect crons are almost always UTC. I think.
Okay, that's interesting.
Well, because
So
you run
what-
them on servers.
Yeah, yes, I recognize that, but I did not immediately recognize that because for obvious reasons. What does that cron string mean? I'll just double check this really fast. And if it's good, I'm just going to put an assert on this. Oh, 10 a.m. every Tuesday. It's every server time.
Yeah. So the 2 is the day of week, the last one. So it's 0 is Sunday, 1 is Monday.
So let's do it this way then. Let's add a time zone. Default TTC not provided. So let's add this in and see if this works. There we go. That looks a lot better. So I think your instinct here is perfectly spot on, which is you can always ask yourself, like, what is a relative time zone to every single date time that you have? And every date time can come in and there's like kind of like a, there's kind of like a variety of questions you could do. But really the way to handle dates very well is what you do is for your use case, you go ahead and come out with a bunch of edge cases that you really care about and that describes a behavior that your users have. And for each one of them, you just go and make a data model. And you notice the first thing that Dexter said was like, oh, this cron string is going to be wrong because it's not time zone aware. He's definitely right on that. Well, we can solve that problem by simply making it time zone aware, by putting an optional time zone and just saying default to UTC otherwise. And let's just see what happens if we don't put in PT. And I want to write another test case. No time zone. And let's get straight to PT and then see what this does. And what's interesting here is time zone is null here, which I think is exactly what I want it to do. Because it's not that I want it to be null. I don't even want it to default to ETC, because that's probably wrong. Only if explicitly provided is probably what the real thing I want is. And the reason I want this is because you can easily imagine, like if I'm a user, I'm not going to write 10 a.m. PT when I go type into a chatbot. I'm just going to write 10 a.m. every Tuesday. And I want
the software is going to know my time zone.
The software should know my time zone because client side, I know exactly what time zone I'm in when I'm accessing the software. So given that, or like when I'm on Google Calendar knows what time zone I'm rendering as right now. So given that, it should be able to go ahead and say, okay, if the time zone is null, use the user's time zone unless they have explicitly passed in a time zone. And I don't even think the user would be mad if you got the wrong time zone there. If your calendar shows ET, even if you're in PT, and you said 10 a.m. every Tuesday, I would expect it to do 10 a.m. ET every Tuesday, not 10 a.m. PT, even though that's the current time zone I'm in, because the UI of what I'm looking at is probably what I intend for it to go do. It's kind of like a best guess effort. But if I didn't recognize the fact that cron zone, like I initially did not recognize that this was UTC or like non-standard time, then I wouldn't have even thought about adding the time zone string. But now what I can do is I can easily convert every single recurring date into an absolute date with just a simple data transformation of applying a today and look up the next time zone from a cron string in a simple Python program. Oops. So I can do something like main.py. Oops. Import recurring date. I could say def next day date recurring date to daytime. Why is it so hard to type stuff out today?
Because you're not using code layer, dude.
Probably, to be honest. Let me go write this down. Oh, I have to go import this. Cron equals date dot recurrence convert cron to datetime. I don't know if this will actually work, but I can figure this out. I'm sure I can write a ChatGPT string to go convert this for me and see how well to go do this. And I can look up how to go do this in a really easy way. And I'll put a cursor agent on this.
Yeah, this is not going to work.
Yeah, probably not.
Because stirp time, that's a format string. It wants it to do hours and minutes.
Actually correct. Make this function actually correct. What I want to do is convert a cron time string that I'm getting from an LLM into a actual hard timestamp for the next timestamp that would occur that matches that cron string. And lastly, I also want to make sure that I'm accommodating for the fact that time zone is sometimes not provided in the recurring date string. So in that case, I just want to default to the time zone that is going to be passed into the next day function explicitly as well. But if the recurring date has a explicit time zone, then use that one. I really like using voice to actually get this thing to work. So I'm sure this will work in the background, and I will have a new function pretty soon. But I think the key part here is for every single test case that you have, if you're not writing each of these test cases and thinking through it, and even over here, if I didn't think through PT versus non-PT, I have no idea if this model is actually going to do the right thing. And I think this problem is actually simple enough, just like extracting dates, that you can actually do it purely with like tiny models. You could probably use GT5 Nano, Gemini Flash. Most of those models should just work. But what's really important here is if dates are super sensitive to you, because perhaps you're doing contract review or something else, every single date needs to be normalized through some process. Because if you just let the model try and do the math of what the date is, at least as of right now, it doesn't work really well. And even if it does look like it's going to work really well, there's a lot of boundary conditions which might fail. For example, leap years in like February 28th, 29th. That might make your off by like 2 days from now be wrong in that 1 year scenario. And you really, really, really don't want that to happen. If you're dealing with, let's say, if you're dealing with like end of year conditions, like December 31st, that's another edge case that's just likely to fail. And while these don't really matter, the problem is questions like doing things like 2 months from now or 5 weeks from now can make a huge difference on what you actually need. And I think the product that I've seen do this the best is actually Superhuman. If for those of you that haven't seen it, I'll show you what I mean.
Oh, it's great.
Exactly. And I
they
think
did
it's
this before LLMs.
Exactly. And I think that's really the hardest part on this, is this stuff, which is like, let me share my screen again.
Oh, we're going to read all your emails?
I have you can see my, like for example, if I want to set up like, oh, no, not that one. If I want to set up like a reminder for this, thank you. I can just say next, remind me 2 hours. Say like
H is the reminder, yeah.
So you can say all sorts of things. You can say like next week, and it just kind of works. You can say 2 weeks, and it just works. It just swaps it to Tuesday, and it does very rational things. Like it says, if I want to be reminded on Tuesday, by default, I want to be replying to on Tuesday at 8 a.m. So it's not even saying just 2 days from now. It's like 2 weeks from now is 2 weeks from now exactly, and it's going to be 8 a.m. on that day. So it's all actually doing a lot of normalization for me, no matter what the user does. And what's interesting about this is not really 2 weekends. It doesn't do that one. This weekend, if you do this weekend, just says Saturday at 8 a.m. And you can say all sorts of weird strings here, but what's really important is it does a lot of normalization for you. And this autocomplete behavior this weekend at 8 p.m. It doesn't work. Saturday, 8. There you go. You can do like more specific things, and like as you can make strings more constrained. And what they're really just doing here is they just have a massive regex parser that just works in a really easy way. And it turns out for date times, this is probably the easiest way to do this, assuming you have some UI interface as you're typing out the date. But if you don't have that, and you're going to go leverage an LLM for this, what you need to do is actually think about the final end experience for the user and what dates are really, really, what I would say, meaningful in the end behavior. Have you seen a product within the AI world do this really well, Dexter? I personally have not. Like, I haven't seen
I
an
like the
LLM
superhuman
calendar.
one.
Yeah, right? The superhuman one works beautifully for me. I've never had a problem with it.
I'm trying to think.
I know contract review software, like a lot of B2B SaaS that I've seen work on this, they've actually done this really well because they're reviewing contracts and like RFPs and other things all the time. And for them, dates are super critical. So what they're doing is they're actually, and it's very clear what their use case is, they need absolute dates. And the problem is the users mention dates in all sorts of formats, but they are guaranteed that they need absolute dates from every single system. So like, for example, in the case of like the recurrence date that we were talking about, what they would want is, let me share my screen again. What they would really want in this recurrence date time frame is actually they'd want us to know, hey, tell me the podcast every Tuesday for this time frame, and they always have a date time of like, here's a range of time, here's the end and start date of the engagement. Give me every occurrence of that. And again, we can imagine exactly how, there we go. I guess it did something here. I don't actually know.
You probably need to UV add some stuff.
Yeah, I probably do. And I can write some test cases for this as well. UV add. Let me add these two. Cool. And then what I found really interesting for them, at least, is what they would say is, given a start date and end date of the full engagement, get every occurrence of this. And you can easily see how if you have a recurring date, you can get every engagement in this given a time frame that matches that date time. And that's actually fairly easy to go do. The other thing you can always do is you can always ask more follow-up questions. So for example, in the case of the meeting is on November 15th, if you know that time is not provided, then you can just make this optional. And then if it doesn't exist, you can just ask a follow-up question in your chat window that says, here's a chat UI that shows you a UI component, here's your date time. And we just don't have the time, and we need you to supply that. And you can either type that in by chat, or you can go enter it in yourself using the UI component. And both of those are fine ways of modifying date times. But I actually think the most interesting way of modifying date time in a chat app is actually to integrate something like Superhuman, where as you're typing stuff out and you're doing some regex string like 2 weeks from now, it just swaps this out. Just like if you're in Cursor and you start typing like @file, and you start mentioning something like, main.py, it just auto-completes all the files that exist, and you can just link to it. And this actually tells the UI element to go inject that in. I think date times are the only real way to use date times in a really random scenario, I think, is that sort of approach, kind of like adding file context.
It's like parsing the user's intent into something structured, some intermediate representation that then can be deterministically evaluated. And we talk about this for generating SQL queries, for generating SVGs, for doing all these things where the model's actually probably not going to token for token give you a really good representation. Like if you say, hey, give me every occurrence of this cron for the next year, it's more likely to get the cron tab right. And so it's like there's this thing in designing like LLM, between the LLM and the user in either direction, is like creating some sort of intermediate thing that is easy for the LLM to write and is easy for software to deterministically compile into whatever the actual result is. Like for SQL,
Exactly.
we have that, we talk about this all the time, is like don't have it write the SQL statements because the logic in SQL is nonlinear. But if the LLM writes actually the compiled SQL, like the AST, the parse tree of like actually how every like token in the tree interacts with every other token, the LLM can write it a lot better. And then your program can turn that back in, decompile the AST into a SQL query to send to the database engine to then recompile it into an AST and build a query plan on the other side, right?
Exactly. And like the second element of this is actually like if the user is saying that, hey, I want to have a podcast every Tuesday at 10 a.m., likely this cron string I save in my database is going to be in UTC time. So what's important is I have to remember that this is UTC time and the user's time zone is PT. And every time I send that string to the LLM, I need to convert that UTC cron string to a PT time string. I in fact want any timestamp that I send to the LLM for that user to always be automatically converted to PT. Because then when
But
the
not
user
by
says
the
what's
LLM.
going, but not by the LLM, so hard coded. So like if I enter another time, it's like, when was this file, let's say part of this timestamp thing is I want to integrate Google Docs. And part of that is I'm going to integrate the last time a file was modified by Google Docs. So I can go do this. Well, I need to do another time zone conversion. Because the user is always going to say, what's the file I edited last night? Well, how can the model do that correctly if the model is getting the time zone in UTC? It's just, it has almost incomplete information. It's sometimes under UTC, sometimes under PT, because the user is referencing the time zone relative to PT. It's virtually impossible for the model to know what last night means because it doesn't know any better. It has complete incorrect information.
Oh, last night is a tricky one. Yeah, because if it's less than 24 hours, then the time zones get really finicky.
Exactly. And it gets even worse than normal.
Yeah. I sent you a whiteboard. I don't know if we want to use it, but this reminds me a lot of something that happens also in internationalization, where like you want this really strong like separation between backend logic and client logic. Yes. And so you have like your like DB, and then you have your like all your backend logic. I don't know why I made this so narrow. And then it gets fetched by the front end, right? And you have your front end data layer. And then you have your like display logic. And when you do strings in a data in an app that is internationalized, this JSON object that comes down to the front end is like, instead of like,
it has
as close to the client as close to the client as possible, you have like, you know, button, and then the text is like, I don't know exactly. Like, there's lots of different ways to do it.
It's like a lookup table, basically. It turns into a lookup table.
It's like,
and you're,
what is it like? Checkout button or dot submit. There's all kinds of weird like syntactic stuff can do, but like under the hood, you're doing something like, lookup translation for this like key, basically. And then in your source code, you have this big, like, giant lookup table of like what every string is in every language. You have like ENUS, and then you have, checkout button, and then you have, submit. And in English, it's, finalize purchase or whatever it is, right? And then in somewhere else down here, you have like, ESSP or whatever is like in like Spanish, right? And your checkout button submit is, I don't know. Do you know any Spanish? Should have picked a different language.
I don't know how to say checkout, but I do know un poquito español.
Yeah, okay. You get the idea, right? And so like the front end logic should be, and so I think you can have the same thing for times, right? Which is like, label, user time, and then it's like, 2025, whatever your timestamp is, and maybe it's 2025, some ISO thing, but maybe it's a Unix timestamp or something else, right?
Exactly. I think it's also, what's really interesting about this is typically if you think about how UIs are built, often dates do live in UTC, and then at the very end, you just convert your date time to, like, you just do a date time conversion only on the display side. Literally not even the data front end side. You just do like date to user lookup time in the browser. And that's what you display. Yeah. And if you're someone like Google Calendar, go ahead. If you're someone like Google Calendar, then like you sometimes have a setting of like, here's the time zone I want to show as a part of your data front end. And then you convert all the dates on the client side to that. But what ends up happening, go ahead.
You go ahead. No, you go.
No, okay. I was going to say the only thing that's really happening here is you have a new thing now, which is your LLM is part of your backend logic. And in this part of your backend logic, what's really interesting is you kind of need whatever the logic you do in here needs to be the same logic as you're doing in this one. because these two are basically talking in the same world, but the difference is the LLM and the display logic, which is what the user is interacting with, and what the logic and the computation, the thoughts are happening off of, are linked. And I think that's what makes this so tricky of a problem. Your code is now split in two different worlds, where typically
and they're very far away from each other.
They're very far away from, exactly. And there's a lot of plumbing work you have to do to make this work and feel right. And I think that's really the bottleneck over here.
Yeah, there's also some like interesting like math stuff happening here. I don't know if you're on the bucketing challenges. If you go to the right a little bit, if your question is something like, you know, how many events happened in the last day, and your day boundary is like over the data set.
Exactly.
Like it becomes very tricky, or like if you want to bucket these events by day, it's like depending on who the user is, they have 20 in a day, or they have 25 in a day, or they have 40 in a day. So like it's not just literally showing the timestamp in the UI. There's all this like logic stuff that is dependent on time and time zones and daylight savings and all kinds of fun things.
And I think it's really interesting because, like, for example, like Superhuman makes an obvious choice, which is if I want to be reminded about an email, I probably want it to happen at 8 a.m. Like most people log into work, there's like a 95 percentile chance that 8 a.m. is a good enough reminder time for emails to come in. So you just have a really good default time. So what you need to do as a user is you need to think really hard about what is your actual like boundary time for like where the timestamps start making relative sense for your problem space, for your domain, and then you need to go discretize it.
Oh, dude, I was going to say before I got here, I was like, we should ask Brian about this. And
that's
what
he was in the chat talking about it, and I know we've had him on before, so I was like, it's almost like a no-brainer to have him come in and answer the last few thoughts.
Yeah, nice to see you guys. Happy to answer whatever I can.
Yeah.
Well, now that Brian works at an applied AI lab, he's definitely a qualified expert to share some thoughts here.
I mean, I handle a lot of this stuff. I think you guys are on the right track, though. It's just like almost interesting to treat the AI almost as a user, to the sense of like if our user's operating in like central time zone, we'll normalize everything that has to deal with dates and times to central time zone. They're capable of reasoning around time zones, but usually you just like don't want them to have to. You know?
Yeah. It's like you want to use their work. I think I view the LLM as kind of like a computation like engine of some kind, and you can choose where the gas goes to, and the gas going to time zone computation is a waste of gas.
Yeah, it's not a good use of your reasoning capabilities. But yeah, I think Dex is saying something correct, where like once you have other things like memory or bucketing that's based on time, that also starts to get really challenging, because then you're starting to make cutoffs based on the user's time zone within a system that might not operate in the user's time zone. So it gets hairy pretty quickly.
I have a question, Brian. Does that mean that to make a system like memory and everything else really work, how do you deal with, like in the case of like calendars, every time I switch into a different time zone, Google's like, hey, do you want to change time zones right now? And I do, because I obviously want to while I'm in the new city. I want to see my meetings in the time zone relative to where I'm at. Do you do the same thing with memories? Where you take memory and then you realign memories to the current time zone of the user all of a sudden and re-snap everything? Or does it kind of, or for latent memories that are really long away, you obviously don't have to do this. But for things that happened recently, let's say within the last week, it feels like you probably should do something.
There's two dimensions here. So you assign each memory bucket to a timestamp, right? And you do want to shift the timestamp into the user's time zone of when that bucket was like marked as, but and you can also recompute the buckets based on the time zones. For example, if you have a daily memory bucket, what counts as the day is going to change based on what time zone you're in, right?
Yes.
I don't do that. I mean, you could. It's going to take a lot more tokens to recompute your entire memory context, right? And I think you hit it on the head. It's not really that important past the day, just 24 hours ago. So we just shift the time zone.
For you, I think it's like your memories are never stored at greater than day granularity. You're never storing things at the hour granularity. So you're never saying, like, you're doing one engagement a day or one engagement. I mean, I guess if you have an email come in at 1 a.m., like, did that, and
We
then you
definitely
moved
do
3
store more
hours.
granular.
Okay.
Yeah, so we go down to 5 minutes now. So we have 5-minute buckets, and then hour buckets, and then day buckets. So it gets crazy.
Yeah, because I think the reason that time I've seen be tricky, at least for like, so for example, the people I know that work in the legal domain, they have a problem. Like sometimes lawyers will use the word tomorrow, and sometimes they'll be awake at like 1 a.m. talking about tomorrow.
Yeah.
And when I'm at 1 a.m. talking about tomorrow, I usually mean after I wake up. I do not mean actually tomorrow. Or I rarely mean the day after, right? It's semantically relevant to what it is right now because it was just today. It's still today, kind of, in my brain.
Yeah, and you'll have that same issue with agents because
Yeah.
like it's a semantics issue, not an infrastructure one.
Yes.
But yeah, we hit all of those things. There is an unhandled edge case that I think Dex was pointing out. Is like if you get sent an email at like 1 a.m. I mean, recently we had daylight savings time, right? Like, and so
Another
another like
The worst
just gonna totally
project
blow up your entire infrastructure.
The worst project, the most humbling project of my entire career was doing this like hourly bucketing into daily buckets for like fast reporting in the future and handling it for multiple users in a single account across time zones and then figuring out what to do the day before and after daylight savings.
That's pretty much our memory problem.
Yeah.
I suspect the hardest problem here and with time zones is one, time zones are just hard even without AI. But what ends up happening is when you toss an AI element into this and your team hasn't spent any time thinking about the nuance of time zone relative to your domain specifically, or like date times or relative dates at all, then users use your product and say it doesn't work. But in reality, you just haven't configured it to work in it anyway. Like it sounds like all of this is solvable. None of this stuff sounds untenable. People just need to sit down, define edge case, and just like understand where the user is going to expect it to work and where does it break. And for example, if it does break on daylight savings times, I suspect your users will forgive you. But if it breaks on saying tomorrow, like at 4 p.m. on a random day, the user will probably be unforgiving on that nature.
And this is the nice part about normalizing the time zone of the agent to be the same as the user is that the agent will also experience daylight savings time, right?
Yes.
And so like it'll wake up an hour later based on when the time is shifted. And so like it might get the planning a little bit wrong if there's like a weird issue, but like overall it's going to basically fix it the day of and it's going to be fine.
Yeah, I guess that's true because if you tell me remind me every Tuesday and then daylight at 8 a.m. daylight savings happen, it happens an hour earlier than you expected or an hour later than you expected, it's still almost correct. Is the way I describe it.
Right. Who's sharing screen? Vibov? You want to go down to the right a little bit? I just pasted an actual example of something that was happening in one of our sessions. I sent this to a friend because I was like, this is super sick, right? So this is a friend of mine who was just on a test account, right? And this is an example of where actually part of our system didn't have the right time zone. So down here it has UTC time zones, right? Because that was like a timestamp for the database.
I'm gonna highlight.
This is just like a reasoning chain of the model, right?
Okay.
So he says, "Oh, the agent's like, okay, this is a UTC timestamp, but I noticed that the user metadata is given in PST, right? So I should now be operating in PST and converting things into PST, which means that like he thought the session was going to be was an hour ago, but it's actually in an hour, you know." And so you can see this down here where he's actually able to reason through this in real time. So you do have some leeway when you actually use these models because like this is 4.5 sonnet or a haiku, by the way.
Yeah.
Okay, this is like
it's not a
dumb
capable model by
having
any
a
means.
seizure. And like having like a thinking too hard, like freaking out.
Well, but in this case, it actually caught an error in our systems where like I should have returned a certain timestamp as a PST timestamp and not a UTC timestamp, and it was able to actually get through that and just like continue as normal and actually fix it for us basically.
Yeah. When I think about like an LLM like I think about this in like the LM prompting infrastructure and everything else. Like, how do you build this context correctly? Like, the right way to do this is actually you as a developer just pass in a datetime object in Python, and somehow, like at some point, the prompt just renders. You just say, I want to render every datetime in this context as PST, no matter what. Everything is always PST, and you just don't think about it. And when the model spits out a datetime object back, it just spits out a datetime object, and you say, no matter what, convert this to PST. And just always give me back PST, or give me back UCT time, assuming that it's PST from the model at all points. That's kind of what you want in like a time zone. You want like an automatic converter, I think, as a developer. And if I were writing like a framework of any kind, that's kind of what I would build if I deal with dates a lot, and dates are critical to my infrastructure. I just say this class always converts in the right way, no matter what.
Yeah, you pretty much want to handle it on your serialization layer to just always be anything keyed to this user's account gets normalized to their account's zone and that's stored somewhere in the database. And we also let the agent change the account's time zone itself. So, for example, like we had a student who usually is in Pacific time, but then they went to India for a month, right? And so you can they'll tell the agent this, like, hey, I'm going to India this month, like we got to change our schedule. And the agent can then change the time zone that's on the account, which means that all of the stuff now is normalized to Indian Standard Time, right? It's an edge case, but it's in case you have users that like move around time zones, it works.
That's actually really interesting, where the model can just like recognize it on their own.
Yeah.
Do you store the event recorded? Like, what was the user's time zone when the event was recorded with each event?
No, we basically just like shift the memory buckets as well as like the event ledger to be logged in the current time zone. So like there are some like weird memory bucketing edge cases where if you bucket a memory in this daily set, like this daily bucket, and then you shift the European time, maybe it shouldn't be in that bucket for European time, but we just don't go back and recompute the entire thing.
Yeah, because you're like, again, you're at most error condition is like off by 1 day, and in
not
that,
even, but yeah,
it's like upper bound. It could be at most off by 1 day. If someone flew to exactly the opposite side of the international date line,
fair,
and did that, and like that's like the worst case scenario. But and they were on the flight working on this thing. Like it involves them working on the flight while magically then also flying, and then be like, hey, why didn't it work? But even in that scenario, I can't imagine the user being upset. I think that's the most important part. It's like understanding when will the user actually be upset versus when can the user understand, and like when can the user understand that, hey, this is like a forgivable sin kind of approach. Sense. That's really cool. Thank you for sharing the chat log. I thought this is the fact that I think Haiku does this is very indicative of kind of what we were talking about earlier. It's like this is not a hard problem.
No.
And if you do it right 90% of the time in your software, if you make a mistake once, the model can fix itself. But if the model is doing this at every single step, it's just going to have a harder time because you can just see the chat log where it's doing this reasoning. It's going to have to do that reasoning. It's overhead on every interaction. And if every interaction is like 5% more overhead, that's just every interaction has a likelihood of failure of 5% more. And you don't want that.
And it's more expensive and it's slower.
Sure, yes, that too, yes. I forgot about that part.
Right. Thankfully, Haiku is crazy fast. I mean, this reasoning chain took, I think, under a second to get back to us streaming.
Yeah, then I guess that explains it. It's like, I think it just goes back to the fact of like, if you do a modicum amount of work to go correct this from your at the serialization layer and just do it the right way, so models don't have to think, then these systems will just work. Yeah. But if you don't do it the right way, then like your app probably won't work, especially if date times are a common part of interactions. For example, like if you're doing a data analysis job of any kind, if you're doing a data analysis job, you're basically screwed if you don't handle time zones correctly. And like you're doing time series data. Like, of course that thing's not working because your users are talking relative time zones and you're not processing them correctly. You got to standardize them. And then Elizabeth brought up a good point of like use ISO standardization. It's a really good technique, but it fails for relative time. So you have to use like some sort of relative time zone technique. And for that, you usually need is that what you guys do, Brian? Do you guys have custom data models that represent like relative time zones? Like like recurrence or something else? How do you deal with those kinds of systems in your world?
We just store everything in UTC and then normalize it on the way out of the API.
Got it. And then, but how do you model recurrence? Or do you have recurrence?
I'm not sure I followed the question.
Like, hey, this event happens every Tuesday at XYZ time, like recurring events.
Yeah, we don't really have like so we have a calendar application, but there's not like a every 2 weeks kind of thing. We just kind of let the model decide, like, okay, let's make the next event, the next event, the next event. And the recurrence also gets somewhat structured in memory as well as like a user preference.
Got it.
The combination of the two tends to work. But I would love to, like, if someone's building a very like SDK-able calendar app that just handles these things, we'd love to use it.
That's funny. Yeah.
Like built for an agent, because then we have to build it ourselves.
We have we tried building recurrence into our previous data model. We built a Slack competitor before we were building BAML, and we did build recurrence into the calendar app that we had integrated. And I can just tell you that it is not fun to data model. The Google Calendar API with the data it gives you for recurrence is not fun. You do not want it at all, because recurrence is, people do recurrence and then they realize that, hey, what people want to do is they want to both edit every element in the recurrence chain, and they also sometimes want to edit individual elements, say this one recurrence is going to change.
Yes.
And there's all sorts of modifications. It's just not fun to data model anyway. Yeah.
And if you edit and move it one day forward and you say edit all future events, that actually means move all the future events one day forward, so they're all still a week apart. Or it's like, no, I just wanted to update the description on all the future ones, but leave them on the same date.
Yeah, exactly. So it's really tricky how you have to go do that.
I have not been confident enough to give an AI the full capabilities of doing that and trusting it to do it accurately.
And honestly, that's probably the best thing to do, where it's like, hey, instead of letting your user shoot themselves in the foot with a broken feature, just don't, like, if you don't have confidence that you can go ship it, just don't do it. And like, you build some UI to make your users interact with it. It's like, hey, build a calendar app, UI only interaction for recurrence. Agent just can't do this. Sorry.
Yeah. So we'll see. But yeah, sorry to crash the session. Figured it'd be interesting to share. But I saw you on Twitter. I was like, oh, I should talk about this.
This is hilarious. I think the chat thread is a perfect articulation of what we were talking about today, happening in real time in a real production app. So I think it's good that it echoes the same sentiment.
Cool. Best of luck in the rest of the workshop.
Oh, I think we're going to close it out pretty soon. We got a hard stop today.
Oh, okay.
Okay. Dexter, anything else you want to share? For anyone else that's interested, we'll go post some of the learnings here. We'll include Brian's chat log. I think it'd be fun for people to go read. But this is AI That Works. Today we talked about dates, times, LLMs. I think next week we're going to do another fun episode that Dexter might have in mind. So we'll see how that goes.
It's a surprise. It's going to be fun.
Cool. All right. Good seeing everyone.
Thanks, everybody.
Bye, everyone.
See ya.